Hi guys. So I got a bunch of questions from people asking me to review the multiplication exit card, a couple of questions on it. So I'm creating this video for you guys just so you can kind of walk through it if you had some struggles with it. The wordiness of the questions is not what you have to kind of get lost in. You have to kind of look at what's the math. So I'm going to look at the second question, which is the one that I think people wanted to look at, and the third question and the fourth question. So about three fourths of the students in the drama club are girls. About three fourths of these girls are in grade 8. What fraction of these students are in the drama club are girls in grade 8? Again, it's simple multiplication here, right? 3/4 times 3/4. So 3 times 3 is 9. 4 times 4 is 16. I can't reduce it. So that means that 9/16 of the girls who are in drama club are, 9/16 of the people who are in drama club are girls that are in grade 8. Okay, so that's kind of the first one. Very simply, it's a lot of words, but really you're just pulling out the two fractions that you needed to know. Okay. The next question I think is the more challenging one, the thinking question. Every year, the school participates in a readathon. About 4/7 of the class collected pledge money for the event. Close to 3/8 raised over $50. So this is people who raised over $50. Okay, is the total amount. So we're still doing the multiplication. First question is, what fraction of the class raised over $50? What fraction of the class raised less than $50? So we're going to multiply these two together, right? This is our over $50 people, and this is the people who donated in the class. So 3 times 4 is 12. 7 times 8 is 56. We can reduce this, right? So if we're reducing by 2, the next answer will be 6 over 28. We can still reduce that a little bit further. We'll get, we'll divide that by 2 again. We'll get 3 over 14. So 3/14 of the class raised over $50. That means the next part of it is, what fraction of the class raised less than $50? So if this is what our over $50 is, over $50, all we're thinking about is to figure out who raised under $50, right? Because think about this again. We went to the amount of kids who donated, and we're looking for the amount of kids who raised $50. And that came out to 3/14. That was over. Now we need to find out how many people went under $50, okay? So in order to do that, we know that in a fraction, a whole is 14 out of 14. 3/14 raised more. So whatever's left is what's gonna raise under. So 14/14 minus 3/14 is 11/14 who raised under $40 or under $50, okay? So again, this question was more of a step of like looking at, okay, once I find this out, how can I use my reasoning skills to figure out this number, okay? So that was part 1 of that question. And then part 2 of that question asked you about, let me just get a new board. Part 2 of that question asked you, if there's 28 kids in the class, based on the previous information, how many students raised over $50? So what I'm going to do is, from that first one, I know that the amount of kids who raised over was 3 over 14. This is the kids who raised over over $50. I'm going to multiply that by 28 kids. So I'm going to write 28 as a fraction. And now it's just straight multiplication. 3 times 28 is, let me just get my calculator out, sorry, 28, 56. 3 times 28. We get 84 over 14. And then we'll just figure out how many times does 14 go into 84. And it goes 6 times. Okay? This 6 represents what? it represents the amount of students who raised more than $50. So if I wanted to find out how many students raised less than $50 out of that 28, I would just do, I know there's 28 students in the class, minus the 6 students who raised more, and the last one would be, the last one would be 22 kids who raised less than 50. Okay, so what we're doing is we're applying the previous information that we got to a new situation to find out the amount of kids who raised that much money. And the final part of that question, the thinking question, was there are 28 students in the class, and based on the previous information, what could you estimate the minimum amount of money raised was? Okay, so I'm just gonna get one more board, and I'm gonna take you through the thinking process here. And this is a really, really good thinking question because it really does do a good job of challenging your reasoning skills. So, if I can say to myself, there are 28 kids in the class. I'm looking to find out what the minimum amount that they could have raised was. I know 6 kids raised more than $50. So I have to ask myself, what's the minimum a kid could raise that's more than $50? Well, that's really easy. It's $51. Okay? And then I have 22 kids who raised less than $50. Well, what's the least amount of money that you could raise that's below $50? Well, that's $1. So now I just do the math. 51 times 6 is 306. 22 times 1 is 22. I'm going to add these up together. 306 and 322 is 328. So based on the fact that there's 28 kids in the class, and I know 6 kids raised $50, more than $50, and 22 kids raised less than $50. What was the minimum they could have raised? Well, it's $328 because the minimum over $50 is 51, and the minimum under $50 is $1. And so I take that information and go there. So this is like a higher level thinking question, which you had to kind of use your reasoning skills. So again, I know that the questions are wordy and maybe they need to be a little bit more clear, but these are directly from, this one was directly from a grade 9 textbook. Okay, so you can kind of see the thought process that needs to go into it. So let's do the last question, which was the cake. So I'm just gonna go just grab this board and just erase it quickly. So the cake question was like, it looked a lot trickier than it actually was, okay? So there was a cake, and the cake was, and Amar baked the cake. John ate 1/6 of the cake. So we know that the cake is made into 6s, right? So to find out how much John ate 1/6. John equals 1/6. So the remaining cake, it's gonna be RC, remaining cake is 5/6, right? Because if it starts at 6/6 and John ate 1/6 of it, we have 5/6 of it left, okay? And then our friend Susan came along, and Susan ate 1/5 of the remaining cake. So I'm gonna do the multiplication. 1/5 times 5/6. Okay, 1/5, 1 times 5 is 5. 5 times 6 is 30. But I want to stop us right here because we should be able to see that we can use a cross-off method. Okay, you could reduce it later, but I know that this is a 5. That's 1. 5 goes into 5, 1. 1/6. So Susan ate 1/6 of the remaining cake. So what's left in the remaining cake after Susan's slice? Well, we have 4/6 remaining cake. And then Miss Chan apparently, came and she ate 1/4. So Chan ate 1/4 of the remaining cake. Well, what's remaining? 4/6. Oh, I see something. I can take out this 4 and this 4. So I'm going to take that out. I'm going to take that out. 1 times 1 is 1. 1 times 6 is. So Chan ate 1/6 of the remaining cake. So what's left after that? I take 1 away from this. 3/6. And then Cindy, good old Cindy, she came by and she ate 1/3 of the remaining cake, which was 3/6. You can see that the fraction is going down by 1 on the denominator. Well, I can get rid of this and get rid of this. 1 times 1 is, surprising, it's another 1/6. The remaining cake is 2/6. And then Luigi, Mario's brother, came by and he had 1/2 of the remaining cake, which was 2/6. Bye-bye. 1 times 1 is 1. 1 times 6 is 6. There's how much left in the remaining cake? 1/6 now. And then I ask you how much of the original cake was left. Well, we know the remaining cake is 1/6. So it is a wordy question. It looks challenging, but you have to be able to figure out what the remaining cake is after each phase.